Hi everyone, I'm Matt Kushel from Test Gauge along with Troy Sieroslawski. We are going to be going over an hour's worth of backflow prevention today. We've got a few things that we wanted to cover, a few things that we see and hear a lot about from customers, and think that would be relevant for this presentation. A little bit about my background. I've been at Test Gauge here for about 10 years now. Prior to me working at Test Gauge, I was a licensed plumber, so still am a licensed plumber, still carry my card. The last 3 years that I was in the field, I was doing only backflow, so testing, repairing, installing, everything across the board, and that's all I was doing full time. I wasn't doing any other type of plumbing at that point. So do have a lot of experience in this. We do a lot of training, we do a lot of CEUs, we do a lot of hands-on training here in our lab, which is where we're coming from, which is where we get to use these areas and try and give you a little more technical hands-on feel through video. So with that, what we're going to do today is we're going to go over testing procedures. Troy's going to do testing procedures. We'll go through the basic steps of those. We're doing this because there is a 3-year recert that is now in effect. So everybody that's got their backflow license, if you want to keep that backflow license, you do have to do a recertification 8 hours every 3 years. So we want to go over the basic testing procedures, and we're doing this because when we're troubleshooting a backflow, this is the starting point of that. We have to test the backflow in order to troubleshoot it, to find out what's wrong with it. And if we can use the test kit and properly know what we're doing, that saves us a lot of time when we're trying to fix something, diagnose something when there's an issue. So we're gonna start with that. We're gonna jump into a little bit of fire protection and then type 2 bypasses on backflow preventers as well. So we've got Troy here. Troy, a little bit about yourself?
Been here about 2 years now, a little over 2 years. Over 30 years background in water treatment before that, so not quite a licensed plumber, but pretty familiar with how things work around here. So
dangerous stuff. So Troy's a good one to demonstrate this, just because then I can nitpick him a little bit while he's going through it, and yeah, we'll go from there. So we're gonna do that, and Troy is our outside salesperson here in the Northern Illinois area, and Southern Illinois, and Central Illinois. Really, most of Illinois for the most part. So you might see Troy on the road, but Troy does help with our continuing ed classes a little bit, just from the perspective of showing guys what to do when they're testing backflows, and has been a great asset to what we do here. So without further ado, Troy, let's jump in. We're gonna test an RPZ. That's the main one that we're gonna go over. We are following state of Illinois procedures. When we're doing this. This is what's being taught now, and we'll keep it pretty simple. We'll try and explain it. I know not everybody's a backflow tester, but we'll try and break down a little bit what we're doing as Troy is going through this and testing this backflow assembly. All right, Troy, all yours.
Well, first thing we're going to do is start by testing for availability out of the test cocks. There is a procedure in which we do open the test cock, so we don't open our relief while we're trying to test the device. So we're going to open up our number 4 test cock first and just leave it run the littlest bit. Like I said, the reason we're letting it run is to make sure that we don't lose any pressure in any zone and dump our relief. This is a smaller device, but if you have a larger device, you don't want all that water coming out of an 8 or a 10-inch backflow.
Yep.
We'll start with the number 1 test cock, check for availability. Number 2 test cock, number 3. Then we can shut off our number 4. We're going to start by hooking up our low side hose to the number 3 test cock, and that's on the back side of the first check.
Yep, and as we're looking through this too, what we're testing, and what you've got to remember is we're testing 3 critical components on the inside of the backflow. Our first check assembly, which sits right here, so test cock 2 would be on the high side, test cock 3 is actually after that first check assembly. Then we're going to test our second check assembly, and then we're going to test our relief valve. So like Troy said, right now he's doing the first check valve, and he's on the downstream side of that number 1 check valve. We want to get flow across that check as we start.
So I'll make sure all of our valves are closed here. I'm going to open up the number 3 test cock, and then we're going to hook up our high side hose to the number 2. Now after that's hooked up, we're going to open up our high side hose.
And we'll go back, and this is a perfect time to start. So when we're doing this, we want to open up our low side bleed at the same time. So we open up our number 3 test cock on our low side, and then we're going to open up our low bleed and run water out through the test cock.
Got it.
At the same time. So right now, I'm just gonna hold this up for Troy. We're gonna see we've got water running out through our bleed out procedures. Okay, so he's got his low now going, and he's gonna open up his high.
We're gonna open up our high side vent and let that run. Mostly we're doing it to get the air out and check for availability on the test cocks once again. We're gonna close our high side and let our gauge spike, and then slowly close our low side. You wanna be pretty gentle with these gauges. It's not hard to mess them up. And our check is settling in at about a 7.4.
7.4, what's the minimum, Troy?
5 on a number 1 check of an RP.
Yep, we've got to hold at 5 PSID. Differential gauge here, this is actually measuring the true differential across that first check valve, or the actual pressure loss across that first check valve. So our true measured value here is 7.4 pounds. We're actually losing that pressure across that first check. That's how this device operates. So for simple math, if we've got 77.4 pounds on our high side here coming into this valve, we just got a 7.4. Try it, quick math. What are we at now after that number 1 check? What's our pressure? We went from 77.4, we lost 7.4.
We're at 71.
We're at 70.
We're gonna start over on this.
Nope, we're going. We're at 70 PSI. This is perfect though. This is, I mean, that's why we do this, right? So we're at 70 PSI, dead on the solid side. So we tested our first check, passed, held above 5. So we're at 7.4. So now this is the tough part for everybody. This is where a lot of guys get messed up in the procedures. Kind of a different way. People that got their license early on in the licensing era, I would say, back in the, probably I think it was 70s, this started, they were taught a different method than what we're actually taught now. So Troy is gonna jump on, do the next portion of our test here.
All right, are we gonna do the back pressure test, or we're gonna do the, okay. So I'm hooking up the vent side to the number 4 test cock.
Yep, and this is a 5-valve test kit. So if you don't have a 5-valve test kit, there's a same procedure as here. We just do a little bit of different transferring with our control valves here.
Okay, so what we're doing is we're gonna take the high side pressure and apply it to the back side of the number 2 check through our gauge. So I'm gonna open up the number 4 test cock. I'm gonna open up my high side to get that pressure bleeding through my pressure gauge and apply it through our vent side to the number 2 check. This is an applied test. We're applying the pressure to the back side of that number 2 check to make sure it's holding correctly. And you're gonna get a little bit of pressure drop just from discompression. And that's normal. We dropped maybe 0.2 PSI on this.
It's gonna be pretty standard. So that discompression is literally, when we put that back pressure on, there's a rubber disc inside these check valves. It's that rubber disc actually compressing and closing just a little bit, pushing forward. That's actually what causes that pressure drop. It's absolutely fine. And you can see when I'm holding the hose, during this part of the procedures, we're not bleeding any water out when we're doing this back pressure test. No water is being bled out of the test kit. We're using the existing pressure that's inside here, okay? And we can drop up to
1 PSI.
1 PSI when we do that back pressure test. 1 PSI is the most they'll allow for discompression. If we were failing here, our gauge would continue to drop until that relief valve opened and started to drip. But because we held up, Troy's good. Now, why do we do this test, Troy? Our next step.
Because we want to do that, what's called the screwdriver test. While this is still hooked up, what we're going to do, we're going to close the number 2 test port and keep an eye on our gauge. The reason we're keeping an eye on the gauge is to make sure that we are not losing any pressure. If we do start to see a pressure drop, that means that your number 2 valve most likely is not holding. And we can actually demonstrate that right here if we just open up our number 2 test valve.
And we see our pressure drop down to 0 right there. So the big thing with these bag flows, an RPZ, double check, any type of device, you cannot have flow. It's got to be in a static condition. So what the screwdriver test does then is verifies that we are in a static condition. All right, so that's very important for the testing procedures. A lot of people do not understand that, don't understand why we do it, and don't understand how to do it. It's very confusing. So we verified then, that means our test results that we've gotten so far are accurate. And we know that we can continue on and finish doing our tests on this valve to make sure everything is working properly. So one thing I always forget now, our next step, is we gotta turn that high side pressure back on. I don't know why I forget that almost every single time. They'll bring it back up. We'll close that. Go ahead, Troy.
We're gonna close number 4 and remove our vent hose. What we're gonna wanna do next is reestablish our pressure from the number 1 check. Just by opening up our low, opening up our high side, close our high side vent, close our low side vent, and reestablish to our original check reading, our first check reading. What we're gonna do now is apply the pressure through the gauge and flood the relief zone to get it to open. That way we can get our relief opening point.
We're going to equalize those.
And we're gonna equalize the pressure. So what we're gonna do is take our high side, open up that valve, and we're gonna apply that pressure through the gauge by opening up our low side. And what we're doing again is equalizing the pressure between these 2 zones to see where our relief opening point is. And it just started dripping and we're about 3 PSI.
Perfect. So what we're doing is we're simulating the backflash from failing right now. We're simulating debris stuck in this number 1 check valve, and that's what Troy did by making this equalize. We're making it equalize, the pressure starts to equalize. When I start to equal out, then our relief valve, if it's working properly, will open and start dripping water, discharging water, depending on the amount of flow. Very critical. The most important component on the backflow is the relief valve. If we've got antifreeze, we've got chemicals going to a boiler system, something on the outlet side of this, and these check valve fails, the fail safe is for that relief valve to open and discharge that contaminated water. So we've got to make sure, obviously everything's working, but to make sure that that relief valve does open. Very critical there. So good job on that one. We'll reestablish everything here.
Go ahead and close our low, close our high, reestablish back to,
Whoa. Now I've got what I choose. That's fine.
Back to our 7.4.
All right, we can shut these off. Now, 7.4 on the number 1 check. First, we should go back to the relief valve. Open it at about a 3.0.
About 3.0.
3.0. Has to open the 4.
2 PSI.
Yep, 2 PSI is the minimum opening point. Opens below 2.0, that's a fail. Needs to be looked at, serviced, taken apart, whatever it might be, to try and get that repaired so it opens at a higher value. Our other thing, here, we've got the imaginary buffer zone. So our buffer is the value between the number 1 check reading and the
relief opening point.
So we had a 7.4 on our number 1 check, that differential. Relief valve opened at a 3. We're going to take that 7.4 and we're going to subtract 3 from it where that relief valve opened, give us a 4.4 pound buffer. The buffer we look at is important. The lower the buffer, the more apt this relief valve is to spit under pressure fluctuation situations. So the higher the buffer, the better. The lower the buffer, when we're into that lower buffer, any kind of little pressure fluctuation on this line, if we're using water somewhere else in the building and we're taking that pressure off this high side here and dropping that down a little bit, it's going to cause that relief valve to spit. It's going to be a nuisance. Doesn't mean the backflow is actually failing, but you have a building engineer, you've got a business owner, you've got a homeowner that sees water on the floor next to this thing, they think that it's automatically something wrong. You go there and test it and find out, tested just fine, but you've got a really low buffer. There could be different times throughout the day that they're getting that pressure fluctuation that's causing that relief valve just to intermittently spit just a little bit. So that's one thing that we do look at. That's why that buffer is kind of calculated. Chicago is the only town that requires it in Illinois that I'm aware of, and they want to see a minimum 3 pound buffer on this valve. So easy way to remember that 3 pound buffer is we've got a minimum check valve number 1 holding at
7.4,
but minimum has to be
5,
and relief valve minimum opening point 2. We got a 3 pound difference right there. That's how I remembered it. I'm not the brightest thing on earth. So when I was going through the testing and learning all this, minimum 5, minimum 2, 3 pounds is my buffer that they're looking at for the city of Chicago. All right, so that handles the RPZs.